Hello once again, geometry students. This is part B of the 10.1 lecture on the area of triangles and quadrilaterals. In this part of it, I just want to go through some specific examples that should help you in trying to navigate the world and answer these problem questions. The first one says, find the height of a trapezoid with an area of 50 square meters and bases of 15 meters and 5 meters. You'll notice in this problem, it's no longer as simple as plug in these numbers, multiply them together to get the area or the volume. Now you have to really think about what you're being asked to do. In this problem, it says find the height of a trapezoid. There's two things that are going to be really helpful in solving these kind of problems. Number one, figure out what formula you need to use. That's one. Apparently I put up the number two. And then number two, draw a picture. All right, so in this example, trapezoid, area of a trapezoid equals 1/2 base 1 plus base 2 times the height. And I can also draw a picture here. So the area equals of this trapezoid. And again, I don't know exactly what it looks like. Maybe it looks like that. Let's see, it's going to be 5 and 15, and the area is 50 meters square. What I need to do here is substitute the values that I know. So the area is 50, 1/2, 5 plus 15. Oh. You'll notice I have now isolated it down to one variable. 5 plus 15 is 20. Times 1/2 is 10. So I've got 50 equals 10h. Now I can divide both sides by 10, and h equals 5. So I just figured out the height, and again, be very careful, I will hold myself to this too. My height is not 5, my height is 5 meters. Single unit for single dimension, length, width, height, time. Squared is area, the amount of surface of something, fabric, paper, siding. Cubic, volume, the amount that can be contained within an object. So let me put my meter there. There you go. Number two, find D2 or diagonal 2 of a kite with an area of 14 xy inches squared, variables and numbers, and a D1 of 4x inches? Well, yeah, don't freak out. Treat it the same way. Okay, I'm dealing with a kite. How do you find the area of a kite? Area of a kite equals 1/2 D1 D2. Step 2, substitute what you know. 14xy. D1 is 4x D2. Step 3, start simplifying it. Now, on this one, I didn't even draw a picture because, I don't think that it might not help me. In a lot of problems, I'm going to draw a picture just for help. Okay, so I get 14xy equals 1/2 of 4. X is 2x. D2. Now, I'm going to divide both sides by 2x. And I get D2 equals 14xy divided by 2x is 7y inches. I'm going to put my boxes around my answers. There you go. So again, some of these problems, especially in more theoretical math, the higher you go up in math, the more they're interested in process, right? Or variables or forces or all these things where your answer isn't just a number. It's a number with a unit, or it's a number with a variable and a unit, because you're learning to solve for a process or a force, or it doesn't matter what you plug into it, but this is what the result would be if you knew what you plugged into it. Cool. The last example here, I'm going to extend my board just a little bit. There we go. It says find the perimeter of a right triangle with an angle of 35 degrees and an opposite side of 12. Okay, well, perimeter equals add the three sides together. Okay, I got my formula. I need to draw a picture on this one because I got to figure this out. So it says, it's a right triangle. Now again, maybe it doesn't look like this, but it's got a right angle. Opposite, 35-degree angle. Oh, yeah, there it is. Whoop, there it is. And then this side is 12 centimeters. Yeah, you know what it is. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Because now I can use my trig ratios to solve for my sides. I can add my sides together and then figure out the perimeter of the problem. Well, if I'm standing there and I know opposite, let's say I want to start with the adjacent side. This is going to be the adjacent. And the HYP, so I'm going to say tangent 35 equals opposite 12 over A. And of course, those are going to end up switching places. I'll do that in a different color. So I've got A equals 12 over tan 35. And then put that in my calculator. 12 divided by tan 35. Remember, you have to be in degrees, not radians. You can see it. The answer, of course, is a whopping 17.14. I'm in centimeters. And then I can use, let's see, well, let's just stick with what we got. We're going to use sine. Sine of 35 equals 12 divided by the hypotenuse. Again, they're going to switch places. I've got hypotenuse equals 12 divided by sine 35. And I get 20.92. And now I can add 20.92 plus 17.14 plus 12 to get the perimeter of 50.06 centimeters. And of course, if it said round it to the nearest tenth or round it to the nearest centimeter, whatever, let's say just round it to the nearest tenth of a centimeter, that'd be 50.1 centimeters. Okay, I hope these examples help. I hope breaking down the video helps too in two little chunks. Speed it up, watch it over. Remember, everything you have learned is now in play. Trig, basic stuff, proof, transformations, similarity, congruence, all this stuff is in play to help you handle what life is going to throw at you.